In this video, we'll figure out where a given function is continuous by analyzing its domain. We're asked to find where this rather complicated function is continuous versus discontinuous. Notice that this function is put together by squaring, dividing, and composing continuous functions. Therefore, it will be continuous wherever it's defined. So our job is to figure out where this function is defined and where it's not defined. In other words, we need to find the function's domain. This function will not be defined anywhere it has a denominator of 0. That's because you can't divide by 0. Well, the only denominator here is this x in the bottom. So in other words, the situation where it's not defined because of the denominator is when x is 0. It's also not going to be defined anytime cosine squared x over x is less than or equal to 0. And that's because you can't take the log of a number that's less than or equal to 0. You can't take the log of a negative number, and you can't take the log of 0. So let's analyze these two situations in a little more detail. Well, there's not much to analyze for the first one. We've already said the issue is going to be if x equals 0, the function is not defined. For the second situation, cosine squared x over x is equal to 0 whenever the numerator cosine squared equals 0, i.e. when cosine itself is equal to 0. And that happens when x is pi over 2, 3 pi over 2, and so on. In other words, when x is pi over 2 plus multiples of pi. Now, for cosine squared x over x to be less than 0, we would have to have the denominator x be negative, since the numerator cosine squared is always going to be positive or 0. So cosine squared x over x is less than 0 when x is less than 0, and cosine squared x is not 0, since that would make the whole thing 0, not negative. So if we put all this together, we see that f is not defined, and therefore not continuous, when x is less than or equal to 0, because if we put this and this together, or when x is pi over 2 plus a multiple of pi. And therefore, f is defined and therefore continuous for all values of x such that x is greater than 0 and x is not equal to pi over 2 plus multiples of pi. In this video, we examined a function that was made up from continuous functions by processes like squaring, dividing, and composing. Therefore, it was continuous everywhere it was defined. So finding the places where it's continuous and not continuous is just a matter of finding its domain.